Welcome to the lecture of semiconductor diode. In today's lecture, previously I have discussed about semiconductor material, and in this lecture I will discuss about the semiconductor diode. Till now, whatever I have discussed, it is only for it is only for a semiconductor, like a same type. Okay, I haven't gone through a junction, and first time I am going through that one. So let us just be an n-type junction. Okay, and now I am if I want to make a junction, like if I will combine these two, then it will form a junction. So actually what happened, the charge carriers are holes as it is p type, and here charge carriers are electron as it is n type. So if we combine each other, then the charge carriers will diffuse to each and every side. So now the carrier will depleted, because they are having the opposite signs, opposite nature. They are having the opposite nature, so that's why they will combine with each other, and now they will get depleted at the space charge which is called as W, which is called as W. And I will take the 0 point here, and xn distance here, and minus xp distance here. Minus xp, why it is minus? Due to Cartesian system, I have taken right hand side as positive and left hand side as negative. 0 to xn and 0 to minus xp. Again, the xn plus xp is my total depletion width, that is W is equals to xn plus xp. And one thing I also want to tell you, that potential drop across the junction, because charge carriers are depleted across the junction. So potential drop across the junction is kT by Q ln Na Nd upon Ni square. The proof of this equation is not in your syllabus. You have to just cover it up. What is the reason behind that? Because the depletion width depends upon the value of concentration of Na and Nd, because Na is the concentration, acceptor concentration, which can be given here, and Nd is the concentration which can be given on N side. Okay, as I have told you, the Ni value for Si material is 1.5 into 10 to the power 10 per centimeter cubic, as for Si semiconductor. Suppose if it is I am telling about Na. Okay, I am telling about Na. So Na will be greater than this value. Na should be greater than this value. Then we can say that it is of p type or it is of n type. And like I have drawn a line here, so that you can see that whether the whole charge carrier will deplete across this rectangular section. No, it is not like that. It may be depleted across here also, but what we will say, by using delta Debye approximation, we can say that the whole of the charge carrier will depleted here. Actually, what happened before the recombination? Actually, what we have done, we have drawn, suppose hole is there and it is moving this side. Now it will recombine here. So this side, one extra electron has gone. So that's why it is having the positive charge. And now this side have taken that electron, so it is having the negative charge. The carriers are depleted, but charges are created across this junction, and it will depend upon the concentration of Na and Nd. If Na is at higher position, if Na is more than that, then what we can say, that the space charge will shift toward Nd direction. I will show you also, like you can see it like that one. Like if you have to remember, that's it. Like if the number of charge carriers are more, then a small portion of that volume can able to consider, like a small portion of p side can be able to neutralize the n side. Okay, a small portion of this one can be able to neutralize this one. So this is the space charge width for which type of junction. This one I am talking about p plus n. If plus sign I have taken, means plus sign means that I am talking about the higher value of Na, that is Na is greater than ND. I am talking about Na is greater than ND. It may happen sometimes that the concentration across both two junctions are not equal, so in that case it will happen. One thing I want to show you that said that I have used step graded PNM. What is a step graded? Means each and every point the concentration of carrier is same, so that's why I have drawn a rectangular section for this one. And plus charge I have drawn because it is plus value, and minus charge I have drawn as minus value. Okay, and the electric field will occur into this region only. Here you can see up to this one. This one is whole W width, and this is for xn side, and this is for minus xp side. You can see at x equal to 0 maximum electric field is there, and 0 at this one. Okay, so what we will do now, we will go for the mathematics of this one. Okay, how we can derive that one. Okay, from Poisson's law in differential form, from Gauss law in differential form, we know that d by dx should be equal to q and d upon epsilon from 0 to xn, from 0 to xn. Okay, so 0 to xn. And what about this one? Minus q na upon epsilon into minus xp to 0, minus xp to 0. Okay, one thing I want to tell you here, that you can see that the gradient, basically it is a gradient sign which will depend upon the, it is a constant. First of all, it is a constant having one gradient, so it is a linear type of, you know the equation of line equation, y is equal to mx plus c. If c is 0, then y is equal to mx. The gradient is given, so it must be a straight line, and the gradient will depend upon how much Na and Nd. If Na and Nd are both equal, then it may be of same, having the same gradient. If Na is different than Nd, then it means this line is steeper. If the what you will gradient, I have told you already in the effective mass concept, in which what I have said, like in that one I have told you that we will see it like that. If you remember, I have drawn these two curves of EK diagram, and I have told you which one has higher gradient. So you can say that curve 1 has higher gradient. Similarly here, like if then it will be more steeper. It will be more steeper if the concentration, if the ND is high, if ND is higher, then Na is higher, then it will be here in this position. Okay, so from there you can do that. First of all, now I am going for the mathematics of this one. So okay, let I have taken that d by dx will be equal to q and d upon epsilon, Okay, if suppose now I am taking the integral, the main thing in integral is the limit. Let I have taken q and d upon epsilon, so I will take the limit as 0 to xn. Okay, 0 to xn. Then if I have taken it as 0 to xn, then what will be the electric field? Electric field at x equal to 0, what is the value of electric field? It is E0. Okay, it is E0, and here at xn the electric field is 0, so E0 will come with one minus sign. Okay, minus q and d upon epsilon into xn, From here you can see, here I have drawn a straight line for x. If suppose minus q and d xn upon, if suppose I will do it from for Na side, then what will become? Then it will come q Na upon epsilon into xp. You can also say that the electric field is having the negative sign because it is for donor charge carrier. Donor have the negative charge, so that's why it will be neutralized. Here you can say that it is on positive, so electric field is charge dependent, also charge dependent, so that's why it is like that only. Now if I will go for the V0, then contact potential, I have told you the value this one, but if I want to calculate it from this also, so you will get half basically what we need, basically we need the value expression of W. We need the expression of W, and we know the value of V naught. So by getting the value of V naught, I want to by getting the value of V naught, I want to get the value of W. By getting the value of V naught, I want to get the value of W. Okay, so V naught will be half E naught into W, the area across this one. Okay, half E naught into W, and from that you can you know that I have to put the value of E naught. I have to put the value of E naught. Then E naught will be, E naught is equals to 1 upon 2 Q into Na upon epsilon. What is this value? This is basically E naught. This is basically E naught. Okay, and into W, okay. And now how I will change this value? Now what we will require to change, we have to put the value of xp. Then from the charge neutrality concept, what should I know? That Na into xp must be equal to Nd into xn. What is the value? Na into xp, this distance, multiplied by Nd into xn. I have told you na that it should be equal, so it should be like that only. So Na into xp will be equal to Nd into xn. xn, what should I kept this value? I will kept W minus xp. Okay, now Na into xp plus Nd into xp will be equal to W into Nd. Okay, now I will take common xp, then it will be Na plus Nd. Okay, now it is W into Nd. Now xp is how much? W into Nd upon Na plus Nd. Now you have got the value of xp. I will keep this value here. Then I will got the value of V naught as half Q Na upon epsilon into xp. Okay, W will square, okay, into Nd upon Na plus Nd. This much value I will get. And for W is equals to how much I will got? 2 epsilon V naught upon Q into Na plus Nd, Na plus Nd, okay, into Na into Nd. You can see here this will go upside, okay, and this will go downside. And what is the what thing is remain? That is W square. So here you can see now the value of W will come 2 epsilon V naught upon Q into Na plus Nd upon Na into Nd. Okay, the whole power of this one is 1 by 2. Okay, you can see it. Now this is the this is the derivation of the whole. Okay, this is the derivation of the whole which I have done, like W. So now you can see that by keeping the value W, I can W is dependent upon how much? Na, Nd, V naught, Q. This all the things whatever I have told you is only and only dependent upon the concentration in both sides. Okay, and one thing more, it is V naught, and I haven't applied any biasing here, as you have seen, and without any biasing I have done all the things. Suppose I will apply the biasing, that I will forward bias or I will negative reverse bias. One more thing I can do, you can see here, if this is the PN junction, and if the positive charge is here and this will be the negative charge. Okay, so you know that the direction of electric field is from positive to negative. Okay, from positive to negative, it is like this only. Okay, it's positive to negative. The direction of electric field is positive to negative. I will take it at E naught. Suppose I will forward bias this diode. Forward bias means positive should be connected with P and negative should be connected with N side. Okay, I have forward bias this diode. If I will forward bias this diode, then what will happen? Then this electric field should nullify, and suppose if Vf is there, then what will the value of E naught now electric field? It will be in opposite direction, positive to negative. You can see here now it is Ef. So E net means net electric field will be in the direction of where E naught minus Ef, or as it is, you know, that electric field is a vectored quantity, you know, na? So E net will be equal to E naught minus Ef. So E naught minus Ef or Ef minus E naught. What? One thing I want to tell you, if I will apply the forward bias voltage across this one, then this depletion charge width will shrink. Okay, it's definite, will shrink. Okay, space charge width will shrink. And if I will apply the reverse bias, then it will swell. So the net, but still the net electric field is in opposite direction. You can see here it is in opposite direction, and like to apply forward electric field. Suppose one thing is happen, that E net is now equal to Ef minus E naught. Then what will happen? Like the electric field which you have applied having too much value, that it can nullify the value of E naught. This is the maximum voltage which the diode can withstand, and this situation will never have to become. Okay, so E naught, whatever the voltage I have applied, it will in the the net electric field is still in the negative direction. Okay, so as the direction to oppose the transformation. But suppose if the if I have applied the voltage, so much voltage that Ef having the larger magnitude, so that it can nullify wholly the E naught, then net electric field will be 0, and this depletion charge will become, this depletion width will vanish out. Now the sudden flow of carriers will occur, and there is no restriction for the movement of carrier, and the whole diode will ruin. So we do not want this such type of situation. Okay, so till now I have calculated the value, derived the expression for W. Okay, and the expression for V naught is given here. V naught is equal to KT by Q ln ND upon Ni square. And now I am talking about forward bias and reverse bias case. So if I will forward bias this diode, then V naught, this value of V naught should be changed from this value. As you know that V naught will come from this NaN, ND and Ni. Okay, and the value of in KT by Q, it is 26 millivolt. Okay, volt temperature equivalent, and you know, and I have told you earlier about this value, and when I will discuss small signal model, then I will tell you more about this value. Presently I can say that it is volt temperature equivalent, that's it. Okay, ln NaND upon Ni square. Okay, so what will happen if I will forward bias? This is the situation when I have applied no biasing. And suppose I have applied forward bias, then forward bias, what will happen? It will be changed, V naught will be changed from V naught minus Vf. What is the value of V naught? V naught has the order of generally 0.7, 0.8, okay, 0.69. It is this will be the order of V naught. And what is the value of Vf? Vf is the value from which we will forward bias extension. Generally we will kept it as 5 volt, 10 volt, 12 volt, 15 volt, like that we will forward bias the diode. But suppose if I will kept the value 5 volt, then net expression of V naught will be V naught minus Vf, as I have told you, and let I am taking the V naught value is 0.7, so 0.7 minus 5 will come how much? Minus 4.3 volts. So minus quantity under within root means imaginary one, and it is not possible. see, you can see here also, as I have told you, that the next net electric field has to be in the net electric field has to be in the direction of V naught or E naught, and Vf is the applied voltage. Okay, so I have said that E naught should be larger, so V naught should be but the value of V naught is from it will be calculated from this expression, which is near about from which we can calculate this value is 0.7. Okay, 0.7. So V naught 0.7 minus Vf, the value of Vf is 5 volt. 0.7 minus 5, that is 4.3. That is 4.3. So minus 4.3 volt with this at the root means this situation is not possible. Means this expression is only and only for no biasing situation or reverse biasing. In reverse bias, what I will do, I will add it on V naught plus Vr. Okay, V naught plus Vr. In that case, V naught plus Vr. So what will happen? Reverse bias, it will come V naught plus Vr. So you can't be able to change. You can't be able to change this quantity. So here I can see that from this value, I actually if I will calculate that V naught minus Vf, then it will showing that it will shrink. But the mathematics is not available with us. Mathematics is not available with this expression, with this equation basically. But for forward bias, for reverse bias, we can estimate the width, depression charge width between these two. Okay, but basically mathematics is the language of science. As sometimes we will say like that, whatever the physical changes will occur, we will describe it in the form of expression, relations and all. So this relation is not valid, and it doesn't mean that space charge width will become 0. So that's why it is not come. No, it is not like that. If we can't be able to show it by using this expression. By using this expression, we can't be able to show it this one. If we want to the different methods are available, from that we can know, but space charge width should be available, but can't be able to define by this method. Okay, now I will show you one numerical, like so that whenever I will solve you numerical in this class. So try to go for the values so that you can get the better idea of that one. Like suppose Na is 10 to the power 20 per centimeter cubic. Okay, Nd is 10 to the power 17 per centimeter cubic. So you have to calculate V naught. Okay, so you have to calculate V naught, then Xn. Then how will you proceed? Okay, first of all, V naught is required. So V naught is Kt by Q. Kt by Q or 26 millivolt multiplied by Ln. NaNd 10 to the power 20 multiplied by 10 to the power 17 divided by Ni is for simplicity. Sometimes Ni is given in this question, it is given as 10 to the power 10 per centimeter cubic. So now it will be 10 to the power 20. Okay, for that you will cancel out, then it will come ln 10 to the 70. One thing you have to keep in mind whenever you are solving with calculator, that it is written ln, not log. So 17 will not be here. You have to calculate ln. That means log to the base e. Log to the base e. So you have to calculate. Then it will come like 1.017 millivolt. Sorry, volt. 1.017 in volt. Now you have to calculate W. W is 2 epsilon. Epsilon need epsilon r. Okay. This is the expression which I have tell you about W. The epsilon will be equal to how much? Epsilon will be equal to epsilon naught into epsilon r. The epsilon naught has the value how much? 8.854. What will be the value of epsilon naught? Epsilon naught is 8.854 into 10 to the power minus 12. No, one thing keep in mind, that whatever the quantity I am giving centimeter cubic. Okay, centimeter cubic. So all the dimensions are given for CGS, not MKS. Okay, it is in CGS, so I have to keep this constant. One thing I can do, whether I can change the whole values and in MKs like per meter cubic, but it is better to keep the constant at that one. So it should be 10 to the power minus 14. Okay, now and 1.017 is the voltage, and voltage or contact potential. Okay, and now 10 to the power 17 and 1001. I have simply calculated the mathematics, and after that the mathematics is involved. That's it, nothing more than that. You can solve this value and get the value of W. By solving, we can get the value of W. How much W will come in micrometer? It will come. Generally, it will come. Having very less value. It will not be like that. That it has the in meter. It will come in meters. So you can understand that it should be very less. So from that you can have the idea. So in today's lecture, what we have done, we have basically gone through the differential Gauss law in differential form. With that we have calculated we have derived the expression of depletion width W, and after that we have gone through the mathematics for that, for different biasing situation. Biasing situation I will discuss with physical means after this lecture, in my next lecture only. But in today's I feel I will give the numerical aspects to you. So that's why these things I have discussed, like V0 minus plus VR, V0 minus VF. These things I have discussed in today's lecture only. In my next lecture I will simply discuss about the biasing of the diode, okay, and and I have solved one numerical for getting the solving the value of W, so that you can calculate the value of W. So I hope you have understand those things, and try to keep learning with the books with you, that is textbooks like Milvan Helkias, Benji Streetman, or you can also go through that with the Boyle Street also. Okay, so now this lecture, in my next lecture I will discuss about the biasing of the PN junction diode in detail. Okay, thank you very much.